Alright, let's pick up from where we left off on the last video. Still in the middle of word problems. You've got to draw your picture, even if it doesn't make a lot of sense. Why this guy's sitting on the top of a tree, Lord only knows. But he's sitting on a tree. So he's up here on the tree, he's looking at his friend down on the ground. Okay, so got to make sure that you get a triangle in there somewhere. So Joey's down here, Mac's on the tree. Angle of depression. You have to remember angle of depression is made with line of sight. So whenever you put him in here, it is 41 degrees, 32 minutes. Make sure that you note, using parallel lines here, that that is the exact same as where the angle of elevation would be. If you keep reading, it says Joey is known to be standing 29 feet from the base of the tree. So go from Joey to the base of the tree, 29 feet. The question is, how tall is the tree? Now, typically the assumption with buildings, trees, anything like that is you assume that they are perpendicular with the ground. So you need your trig function. This is from your angle, you have opposite, you have adjacent, so you got to set it up again. Tangent, 41 degrees, 32 minutes is x over 29. Cross multiply is x equals 29. Tangent 41 degrees, 32 minutes. And I get 25 degrees, or 25.68. They said round, so you need 26 feet as your answer. So option B is the one that we need. Moving on and looking at number 8, you are getting into bearings. There's two ways to know it. Obviously the word bearing is there. And then whenever you get to your angles, this is the ones where since you have one angle, you are coming from north and you're rotating in a clockwise fashion. So make sure that you start in the middle of your page and you don't restrict yourself when you're doing your drawings. Otherwise you're going to get irritated when you run into other stuff. So you have a ship and he travels 93 kilometers with a bearing of 29 degrees. So just give yourself a little distance so you get away from your little coordinate thing. 29 is in between, or how far you rotated from north. So that's where our 29 is. Then it says that he changes his bearing and he swaps to a bearing of 119 degrees. So he turns. Okay. Now when you figure that out, keep in mind this is 90. Okay. So 119 minus 90. I hit the wrong button. 119 minus 90 is 29 degrees. So that should be a little bit familiar to you. The question is, what's the distance from starting point to ending point? Okay. If you get to investigating here, using your parallel lines, because north is always parallel to north, 29 degrees here is actually equivalent to 29 degrees here. So that means this is the, and we know this is 29 degrees, so this is the complement of 29. So 29 and its complement make 90. That's all you need. So this piece is the hypotenuse. Okay. Now we put the 93 here. I did not put the other one in the diagram. 113. So basically all we need is Pythagorean theorem. We have got 93 squared plus 113 squared equals x squared, or c squared, whichever one you want to use. You basically just need your calculator. When you type those in, I really wouldn't take the time to write down anything else. Just make sure you do square root of answer. And we are rounding to the nearest whole number, so 146 is what we need. Option D. Then you're going to get the other version of a bearing. They will use the term to tip you off, but hopefully the notation also tips you off. This is coming from the north-south line. You would be going either east or west whichever one is noted. Let's see here. We've got radio direction finders are set up at points A and B. Again, don't restrict yourself. Start in the middle of a wide open space. And they are 8.68 miles apart on an east-west line. So that's the reason we just did them side by side. Okay. From A, it is found that the bearing of a signal, so we need our little coordinate things, of a transmitter is 54.3 degrees east of north. So, coming from north, there we go, and right in here, that is 54.3 degrees. All right, and then coming from B, it says that this little angle right in there is going to be 35.7 degrees. We are having to head west, so that's the reason it's on the other side. You got to go in the westwardly direction. It says find the distance from the transmitter, which is here. I just didn't label it. From your transmitter to B. So there's X. You probably want to look at your picture just a little bit. The only thing that you might feel like you've labeled definitively is this side here. When you get to investigating, you need an angle on the inside. If you come over here and you say, okay, 90 minus 54.3, you come up with 35.7, which should ring a bell because, hey, you got 35.7 over there. What's lovely about this is if you come on the other side, that means 54.3 is right here. If these two are complements, then that means there's your total of 90. Therefore, the other angle must be 90. So this bottom is your hypotenuse. Now, you can use whichever approach you want to, but you are going to have to use some trig here. You have the option of using angle A or angle B, but you're going to have to incorporate this side over here because that's what you're looking for, and you're going to have to use your hypotenuse. I'm just going to use A. Just because it comes first in the alphabet. From A, this is opposite, and this is hypotenuse. He doesn't change. So sine of 35.7 equals x over 8.68. Put it over 1 and cross multiply. 8.68 sine of 35.7. And it's just a matter of typing it in. I've got 5.07, and they've got their miles on it, so it's nice to keep up with your units. There we go. Now let's keep going. This is one that we didn't do specifically in class, so you might want to make sure you get a good look at it. This right here, you need to interpret that and be able to translate that into a distance, because if you're traveling for 4 hours at 20 miles per hour, you should be able to use D equals RT and give me that is 80 miles. Okay? Pretty intuitive right there. What you've got to understand, it never uses the word bearing. But since we're talking about boats here, this is bearings. And since it's one angle, you're doing the one that comes off of north. Okay, so if we're doing 103 degrees and 4 minutes, we passed 90. The question is, how much did we pass 90? So you basically just take 90 off, and you end up with, I keep doing 10 here. Let's see here, that's going to be 13 degrees and 4 minutes. I want to do 0.4, but it's not. Okay, there we go. That's how much this little portion is. Let's see here, it says, how far south has it traveled to the nearest mile? So that's the weird part. You've got to understand, what is that question really asking you? It's not asking you how far did the boat travel. It said how far south did it travel. South is straight down. That's what it wants to know. Just how far south, not your easterly direction, just the southern part. So construct yourself a triangle. Obviously, you've got your right angle there. It just wants to know how much of it is south. You know that this angle right here is the 13 degrees 4 minutes. Well, remember, parallel lines don't work yourself into the grave. Use what you know and make it easy on yourself. You know that little angle in there is 13 degrees, 4 minutes. Okay, if that be the case, you do need to know one other thing. This little 80 miles, that is how far he went. So you've got opposite, you've got hypotenuse, that would be sine, 13 degrees, 4 minutes is x over 80. Cross multiply, 80 sine 13 degrees, 4 minutes. And then it's just a matter of typing it in and working it out. Just make sure you do plus 4 divided by 60. And they rounded, so we're at 18 miles. There we go. Not too bad once you understand what this is talking about. It just wants to know straight down, because when you first draw it, you don't get a triangle. When you access this question, then you kind of have to fill in the rest of this triangle. Then it's not too bad. Okay, this is probably the most evil problem on the test. And I'm going to be doing good to find space to get it in here, so if I write small, please forgive me. This one right here, you have to use several, you have to use 2 equations and set them up. You need your small triangle. Oh, and we do need to define this right here. This space is x. Now, our goal in the end is what is h. And it's just going to take a little while to get there. So, let's just use the small triangle. We know that tangent of 51 degrees, 20 minutes is h over x. Okay? That part we know. Now let me roll this up and get him out of the way. From the other triangle, we know that tangent of 26 degrees, 10 minutes is h over x plus 99. Now, we need to cross multiply those things, because our goal is to get it into something that we can combine and get one equation. So if you cross multiply, stick all that over 1, or just say multiply both sides by x. That's going to be x tangent 51 degrees, 20 minutes equals h. And now over here, we're going to have to cross multiply. Now I'm going to skip a step, because when I cross multiply, I've got to multiply this binomial times my trig function. I'm going to distribute while I do it. So I'm going to have tangent 26 degrees, 10 minutes times x, and let me put that x in front, plus 99 tangent 26 degrees, 10 minutes, and all of that is equal to h. So I distributed my x plus 99. So I got my x and I got my 99. Both of them was multiplied times tangent. Now look, I have both of those equal to h. If I set those equal to each other, we have us a nice little equation. It just takes forever to write it out. Okay, now our goal here is to find out what x is, and I may not make it in the time allotted. We need to take this term over, so our x's are on the same side. Now I'm going to skip a step, because I need to factor out the x. So I'm going to take out the x. And actually, I tell you what, since I'm running out of time, let's just pause right here, and I'm going to pick up with this problem in the next video, okay? So we'll pick it up right here.